A UFER ground, when installed properly, negates the National Electrical Code, or NEC, requirement for a secondary electrode such as a water pipe or ground rod. However, it is crucial to understand that the cold water pipe and gas pipe still require bonding to the main panel ground according to NEC section 250.50, irrespective of the presence of a UFER ground. The rationale behind this is twofold. Firstly, a correctly implemented UFER ground establishes a low impedance path to earth, satisfying the NEC grounding stipulations for service equipment and exposed conductive parts. Secondly, water and gas pipes cannot be considered a reliable grounding path, as they are susceptible to disconnection or degradation over time. Bonding these pipes ensures a continuous and safe ground path back to the main panel, thereby mitigating potential electrical hazards. Now let's delve deeper into the specific code sections and the reasoning behind them. A UFER ground, also known as a concrete encased electrode, is a grounding electrode encased within concrete. Typically, it consists of at least 20 feet of bare copper conductor, no smaller than number 4 American wire gauge, encased within at least 2 inches of concrete in direct contact with the earth. This type of grounding electrode is considered very effective due to the large surface area in contact with the earth and the relatively stable moisture content of the surrounding concrete. According to the NEC, a UFER ground can serve as the primary grounding electrode for a building or structure. If a UFER ground is properly installed and meets the requirements of NEC section 250.52, then the NEC does not mandate the installation of a supplemental grounding electrode, such as a ground rod or water pipe electrode. However, the NEC does require that certain metallic piping systems be bonded to the grounding electrode system. This requirement is primarily found in NEC section 250.104, which addresses bonding of piping systems and exposed structural metal. Specifically, NEC section 250.104 covers bonding of metal water piping systems. It states that metal water piping systems that are likely to become energized must be bonded to the service equipment enclosure, the grounded conductor at the service, the grounding electrode conductor, or the grounding electrode system. The point of connection must be accessible. The bonding jumper must be sized according to NEC section 250.66, which provides guidance on sizing grounding electrode conductors. Similarly, NEC section 250.104 B addresses bonding of other metal piping systems. This section requires that metal gas piping systems and other metal piping systems that may become energized be bonded to the grounding electrode system. The bonding jumper must be sized according to NEC section 250.102, which provides guidance on sizing equipment grounding conductors. It is important to note that the purpose of bonding these piping systems is not to use them as grounding electrodes. Rather, the purpose is to ensure that they are at the same electrical potential as the grounding electrode system, thereby minimizing the risk of electrical shock if they become energized. This is particularly important for gas piping systems, as a difference in potential between the gas pipe and other grounded metal objects could create a spark hazard. Even with a properly installed UFER ground, the NEC still requires bonding of metal water piping systems and other metal piping systems, such as gas piping, to the grounding electrode system. This is because these piping systems may not provide a reliable grounding path due to factors such as corrosion, dissimilar metal connections, and the use of non-conductive fittings. Bonding these piping systems to the grounding electrode system ensures that they are at the same electrical potential as the ground, thereby minimizing the risk of electrical shock or fire. In summary, while a UFER ground can eliminate the need for a supplemental grounding electrode, it does not eliminate the requirement to bond metal water piping systems and other metal piping systems to the grounding electrode system. These bonding requirements are essential for ensuring electrical safety and preventing electrical hazards. The code mandates these measures to protect individuals and property from potential electrical dangers. Understanding the interplay between UFER grounds, secondary electrodes, and pipe bonding is crucial for ensuring electrical safety and compliance with the NEC. A UFER ground serves as an effective primary grounding electrode, where the bonding of water and gas pipes remains a critical safety measure, regardless of the UFER ground's presence. Adhering to NEC Section 250.50 and related sections ensures a comprehensive and reliable grounding system. A properly installed UFER ground provides a low impedance path to earth, meeting the NEC grounding requirements. However, water and gas pipes are not reliable grounding paths due to potential disconnections or corrosion. Bonding ensures a continuous ground path to the main panel, protecting against electrical hazards. The NEC does not require a secondary electrode if a UFER ground is installed correctly. The cold water pipe and gas pipe must still be bonded to the main panel ground under NEC 250.50 regardless of a UFER ground. The purpose of bonding is to ensure that these metallic systems are at the same electrical potential as the grounding electrode system, reducing the risk of electrical shock or fire hazards. In addition to the points discussed, it's important to consider the practical aspects of implementing these grounding and bonding requirements. Firstly, ensure that the UFER ground is installed correctly during the construction phase. This involves proper placement of the concrete encased electrode and making a reliable connection to the grounding electrode conductor. Secondly, when bonding water and gas pipes, use appropriate bonding clamps and conductors that are sized according to the NEC. Make sure that the bonding connections are accessible for inspection and maintenance. Thirdly, regularly inspect the grounding and bonding system to ensure that it is in good condition. Look for signs of corrosion, loose connections, or damage to the grounding electrodes or bonding conductors. Finally, if any changes are made to the electrical system or the building structure, re-evaluate the grounding and bonding system to ensure that it still meets the requirements of the NEC. Now let's consider some common scenarios and how the NEC requirements apply in those situations. In a new construction project, the UFER ground should be installed as part of the foundation. The grounding electrode conductor should be connected to the UFER ground and run to the service equipment enclosure. The water and gas pipe should then be bonded to the grounding electrode system at the service equipment enclosure or at another accessible location. In an existing building where a UFER ground is not present, a supplemental grounding electrode, such as a ground rod or a ground plate, may be required. The water and gas pipe should still be bonded to the grounding electrode system regardless of whether a supplemental grounding electrode is installed. In a situation where a water pipe is made of non-conductive material, such as plastic, the water pipe cannot be used as a grounding electrode. However, the metal components of the water system, such as valves and fittings, should still be bonded to the grounding electrode system. It's crucial to remember that electrical codes and regulations are subject to change, so it's essential to stay up to date with the latest requirements. Consult with a qualified electrician or electrical inspector to ensure that your grounding and bonding system complies with the current edition of the NEC. To summarize the key takeaways, firstly, a properly installed UFER ground can eliminate the need for a supplemental grounding electrode. Secondly, regardless of whether a UFER ground is present, metal water and gas pipes must be bonded to the grounding electrode system. Thirdly, the purpose of bonding is to ensure that these metallic systems are at the same electrical potential as the ground, reducing the risk of electrical shock or fire hazards. Fourthly, grounding and bonding systems should be regularly inspected and maintained to ensure that they are in good condition. Fifthly, consult with a qualified electrician or electrical inspector to ensure compliance with the current edition of the NEC. Understanding and implementing these grounding and bonding requirements is essential for ensuring electrical safety and protecting individuals and property from potential electrical dangers. The NEC provides detailed guidelines for grounding and bonding, and it's crucial to follow these guidelines carefully to ensure a safe and reliable electrical system. Remember that electrical work can be dangerous, so it's always best to consult with a qualified electrician if you're not comfortable working with electricity. The electrical safety is paramount, and proper grounding and bonding are essential components of a safe electrical system.